Right, now we're on to lesson 2.1, which is all about relations and functions. Some of this should be review, but some of it may also be new. We've done relations and functions before. So for our first part, we're going to look at graphs of relations. One thing just to remember here, a relation is just a set of ordered pairs. So even just a set of one ordered pair, so one point in itself makes a relation. Having a couple points on a graph like this, or making a table of it, that's also a relation. It's just a set of ordered pairs. So on your graph, yours will probably be blank. I want you to put a point, put a dot on this spot here, which is -7, 5, one here at 0, 0, one at 2, 4, and one at 4, -3, and how about at 6, 6. Okay, just a few random points here. Just make sure they get put out in those spots. We're going to go over domain and range. So in this one, we're just looking at the domain and range of our graphed relation. Now the domain is just all of the x values in a relation. It's what the x values can be according to whatever we have. So here we have a graph, so we have to look at the points. We could be given a table, we could be given an equation. In any of those circumstances, we're just being asked, what can x be? Now, when it's just all these points, we don't connect them with a line or anything. So it's literally saying, these are the only x and y values possible. So on this point, the x value is a -7. On this one, the x value is 0, 2, 4, and 6. So we would say the domain is, we start with a curly bracket, -7, 0, 2, 4, and 6. Make sure you end with that curly bracket and separate them each by a comma. This is just saying these are all the possible x values in this relation. Range is going to be very similar. It's just all the possible y values, or all the y values that there are. Now notice, in this case, we started with our lowest value and worked up to the highest. Now you might be tempted to think, okay, -7 right here is matched with a 5, so we should start with a 5. That's actually not true. In domain and range, you always start with your lowest value first. So even though this -3 for a y value doesn't match with this -7 for an x value, our range will still start with the lowest value. So -3 right here, moving up to a 0, moving up to a 4, a 5, and a 6. Okay, so -7, -3, that doesn't make one of these points. Okay, there isn't a point right here. So we're not saying that these two have to match. Domain is just saying these are the possible x values. Range is just saying these are the possible y values, always ordered from lowest to highest. Okay, so that's how you find the domain and range if you had a graphed function, or should I say a graphed relation. All of the points on here, you would just write each one individually. The vertical line test is a way to see if a relation is considered a function. So literally, all you're doing is taking a vertical line. Oops, that one is a very thick vertical line. Properties, we can make it much thinner. There we go. You're going to take a vertical line and see if it crosses more than one place. So notice this vertical line that I have, it will not cross more than one spot on this line. So I know yours are all blank. I want you to take the time to draw a diagonal line in your first graph, a vertical line on the second graph, a big parabola or U shape going upwards like this on the third graph. This is what's called a step graph. So darken in circle here all the way to a light circle or open circle, and then right above it darken in straight over to open, darken in straight over to open, up here darken in straight over to open. May look something like that. On this one, graph a circle, just draw a circle on your graph, and this one do another parabola like this, but only have it open sideways. So your vertical line test is just a way to say, all right, if this vertical line will cross more than one point at any vertical line that I draw, then it won't be a function. This one is always crossing just at one point. So it's always crossing right where my cursor is at there. It never crosses more than one point on this line. So we would say, I'm just going to use y for yes. This one is, in fact, a function. Vertical line test on a vertical line, we'll notice that everywhere is being touched. Here it's nowhere, and that's okay. This vertical line can touch nowhere and it still be a function. The problem is right here, this vertical line touches more than one point. It touches this point, this point, this point, this point, this point, this point, this point. Every single point right here, my vertical line is touching, which means no, this one is not going to be a function. On our U shape on this parabola, it's only touching one point all the way throughout. No matter what, even as it continues to go upwards into infinity, it's still every moment going up just a little bit and over, or up maybe a lot and over just a little bit, up a lot, over a little bit. So this will never touch more than one point, always just the one. So this one is yes. Yes, this one is a function. If we jump down to this sideways parabola, again, touching nothing is okay, but if I were to draw my line right here, notice it touches here and here, meaning no, this one will not be a function. It touches more than one spot. Same with this circle, touches nothing, over here touches nothing, right here it's touching 2 points now. We don't want that, which means no, not a function. Now for this step function, here where it's going through that kind of open spot, that open circle is saying that there's nothing there. We're not touching anything. So technically, right here, it's not touching anything. Once it's on the line, it's intersecting at one point. Now when it goes like this, it is touching right here. A filled in circle means it is being touched, and it's not right here, which means technically our vertical red line is only touching one point right up here. So when I move it over here, it's only touching one point down here now. So it's only touching one point all the way throughout right here, still technically only touching up here, not down here. Now all of a sudden as I move over, it jumps down and is touching right here. So you can see why that kind of looks like steps. It's kind of these floating steps. That's what makes it called a step graph. And technically, our vertical line is always only touching one point throughout. So yes, this one does make a function. So let's do equations of functions and relations, looking at graphing a line. So if we need to graph the relation that's represented. Now notice this relation, it's not given to us as a bunch of points, nor is it given as a table, it's given as the equation. Now we could make a bunch of points, we could make a table, or we could just graph it using our y equals mx plus b knowledge. In this case, our m, 3, is our slope, and our b, -1, is our y-intercept. So we know right here, -1 is where we're going to start, and we know from our slope, 3, well, that's kind of like saying 3 over 1. So we're going up 3, 1, 2, 3, over 1. Up 3, over 1. Up 3, over 1. Okay, so now we've got a few points made. In fact, going the other direction, we're going down 3, over 1, down 3, over 1, down 3, over 1. Now we've got a few points there. We can just simply connect those points, and there's our graph. Okay, this graph means, or this line is saying every point on this line counts for our relation. Now it might be kind of hard to write down every single point because a lot of these will have decimals in between there. And in fact, even from here to here, there's an infinite number of points because they're so small in between them. That's why it creates a solid line. So we can't write down every single one possible. That's why we write it as an equation. Now from here, we need to find the domain and range. Now it might be kind of weird to write down your domain and range because technically it's every number possible. What x values are possible here for writing our domain? Well, every x value is possible. I can go as low as negative infinity and there'd still be points. I can go as high as positive infinity and there'd still be points way up here. Same thing with y. I can go as high as I want, I can go as low as I want. So when we are writing our domain and range in set notation, by set notation we're saying we're just putting everything in a range. We're not saying individual pieces, we're saying all of this included. We would write it something like this. The domain, then put a semicolon or a colon here, start with the parentheses and say negative infinity, comma, positive infinity, and your parentheses. Now, a closed or a smooth parentheses like this means up to but not including. Now, technically for infinities, we have to say up to but not including because these are not exact numbers. But this is saying everything within here counts in our domain. All x values count for our possible x values. Range is going to be similar. All the range values work. So anything in between negative infinity and positive infinity works. So we use that curved line to say up to but not including negative infinity, up to but not including positive infinity. Okay, so that's how you'd write your domain and range. Let's say our graph makes a curve though. Okay, so in this one we're going to graph the relation represented by x equals y squared plus 1. This one isn't as easy to graph yet. We will know how to do it later. But for right now, I'm going to tell you on ones like this, make a table. If there's a squared in there somewhere, make a table. Also, recognize that usually we have a y out here and x is here. This time they're flipped around. So we're going to pick values for y instead of picking values for x. And I'm just going to use all of the y values from -3 up to +3. And I'm also going to just do them right next to each other. So 0, 1 and -1, 2 and -2, 3 and -3. And I'll show you why as we work them out. If we use y as 0, 0 squared is 0 plus 1 makes 1. If we use y as 1, 1 squared is 1 plus 1 makes 2. Well, what if we used -1? -1 squared means -1 times -1, which is now a +1, plus 1 is still 2. So these two made the same number. Let's do 2 then. 2 squared is 4, plus 1 makes 5. -2 squared means -2 times -2, which is +4, plus 1 is also 5. Let's try 3. 3 squared is 9, plus 1 is 10. Same thing. -3 squared means -3 times -3 plus 1 is going to come out to a +10. So this graph will look something like this. We have 1, 0, 2, 1, 2, -1, 5, 2, 5, -2, 10, 3, and 10, -3. So these are the points that we found. And remember, because it's an equation like this, all of these points in between will also fit. So we have to connect these like so. It's going to go on forever. Notice that this is making that parabola, kind of that U shape, but it's on its side. If you tried a vertical line test here, notice it's going to hit 2 spots. Oops, grabbing the wrong piece. Grabbing it again. There we go. Anywhere along here, it'll always hit 2 different spots. Except for right here, it only hits the tip, it hits that vertex, and over here it doesn't hit anything. most of this piece, it will only hit 2 spots. So because our vertical line test is crossing at more than 1 point every time, we know that it's going to not be a function. So we can just right away say not a function. Oh, close that off. Okay, so that was jumping ahead a little bit. Before we can go on though, or before we say that, we also need to find the domain and range. Now if we look at all of the possible x values, looking at this graph, we can't have any x values over here. We can't have x is 0. We can't have like a half or 3/4 or anything. The very first x value we can have is 1. And we do include 1. And it goes from 1 all the way to infinity. So our domain would have that kind of square bracket to say we include 1 and we go all the way out to positive infinity. We use our lowest value all the way out to our highest value. So this would be the domain of this function. Now even though our y values are growing out slowly, they still are growing forever. It's going to forever go this way, forever go this way. So technically, our range in this case goes from as low as negative infinity to as high as positive infinity. So this would be our domain and range, and we know that it is not a function. For our last examples here, we're going to be looking at evaluating functions. Now if we are given two functions, f of x, which is x cubed minus 3, and h of x, which is 0.3 x squared minus 3x minus 2.7, we need to find each value. So for for our first example here, we have f of negative 2. Notice that negative 2 takes the place of x in this function f. So f of negative 2 means that we look at f of x, and everywhere that was an x, we now just replace with negative 2. So f of negative 2 means put negative 2 right here. So negative 2 cubed minus 3. Remember, cubed means that number times itself and then times itself again. So negative 2 times negative 2 times negative 2 becomes a negative 8. Negative 8 minus 3 is negative 11. So f of negative 2 is negative 11. All you're doing is just plugging in this value into this equation. Same thing for b. We have h of 1.6. You might need to use a calculator on this one, and that's okay. We're going up to this equation and just replacing all of the x values with 1.6. So h of 1.6 means 0.3 times this amount in parentheses 1.6 squared minus 3 times this amount 1.6, and all of that minus 2.7. Now remember your order of operations. When we have an exponent here, we need to do 1.6 squared first, then we'll multiply it by 0.3. So this piece becomes 2.56. This piece that was multiplied became 4.8. So from here, it now looks like this. I'm going to combine negative 4.8 and negative 2.7 and get negative 7.5 or minus 7.5. I'm going to distribute or multiply this 0.3 times 2.56 and get 0.768. So 0.768 minus 7.5 is negative 6.732. So that would be how to evaluate that function. For our last one, it'll be a little bit different. We're not plugging in an exact number. We're plugging in a new value. So instead of plugging in an exact number in for x, up in f of x, we're just going to replace all of these x's with 2t. So f of 2t equals 2t is the amount that's now cubed minus 3. Remember, cubed means times itself times itself. So 2t times 2t times 2t, which comes out to an 8t cubed, and then minus 3. Well, we don't have an amount for t, so we can't plug it in. And this term is a t cubed. This term is a constant. There's no variables with it, so we can't combine them. So in the end, that will just be our answer. F of 2t is 8t cubed minus 3. That'll wrap it up for that lesson.